Hey everyone, and welcome to the fourth video of this math library programming series. So, like I said, today we're doing the matrix file. So let's get started with that. So first we need to know how many rows and columns it has, and we also need some kind of representation of it. And let's get this object set up. Um, so we're going to make two constructors. One will take in the user rows and columns. And then we're going to set up the array representation of the matrix. What do you think about this? So rows and then columns, or columns and then rows? It's rows and then columns. All right, let's double checking, just picturing what this thing is going to look like. And then let's set this thing up. We'll initialize this to a zero matrix. So let's make a loop. I'm going to draw this out somewhere, and I'll clean it up later. Okay, so we're first going to populate this with more arrays. So we're starting with the rows. We don't know what I is, we know what R is. R less than rows, let's make a temporary array to store this. And just make sure that this works. We'll override the string function right now. So since you've seen me done something similar like this in the vector file, I'm gonna do this off camera. I'll be right back. All right, so it looks like our two-string function worked. So we're gonna do something similar in the other constructor that I said we're gonna make. But rather than asking for both the rows and columns, we're just gonna ask for just the size of it, and this will just make our matrix this will just make our matrix the square matrix. So all right, so I tested out our toString function. You can see down here on the console, it works out. So now we're going to make another constructor in here that will only take one input. And this one will make a square matrix. So let's do right. So in a square matrix, the rows and columns are size the same, and we'll just copy this loop. So now if we go in here, if we give it arbitrary size, there you go. See 4 by 4. Now I'm going to do this one first. So so we're going to be setting values in the matrix. So we're going to say like public void set. We need to specify the row and column, and we want to set it to. So we're going to say matrix at row and column is equal to this value right here. So error handling, I'm handling that like in between recordings, so I don't bore you with throwing exceptions. I think you've seen me do that enough times. So this is the set function. So start with a small matrix. All right, and then we're going to set. So this is our matrix right now. It's going to print out twice. Let's give it no arguments, so it'll give us like a space in between. Then let's do matrix dot set 0 0 2 1 and row 0 column 1, that's right here, set to 3.2, set row 1 column 0, so that's this cell right here. I'm going to set that to, I don't know, -1. Let's leave it at that. So this last one right here should still be 0. So we print this out, which hopefully see what we expected. Yep, there you go. So let's do some basic matrix operations. So first one, we should be able to multiply matrices. Should be before we do this. There's one that I want to do, and that is take the transpose of the matrix. So the way transpose works is in notation wise. I think it goes like a at ij. So we're going to assign this value, the value of a at ji. Does that make sense? So basically switching values between, so we set the value at row and column to the column, to a matrix at index column row. I'll put that into writing so you can see how it works. Let's do public void. I want to make these guys void for now. Maybe we'll return a value, so in case we want to set a value, you want to save this value somewhere, we can do that. So we're going to transpose. Yeah, that's nothing to do over there. Also want trans as the new. What is it? Double. So it's already we're switching. Okay. So already we're switching. We're flipping the dimensions of the matrix, so everything can still fit in. I went right through this the same way. Let's write a loop. No, we don't need to do this. Let's go jump straight into another loop. I'm gonna say this right now, like if you guys have like algorithm suggestions for, hey, like you can be more space efficient if you write your algorithm this way, or it could be more time efficient if you do it that way. Do say so. If you're studying computation, that's just perfect. So yeah, I know most of you are here for uh, to check out the back work that we need to do for Desmos. Yeah, so just like a quick announcement type thing. So yeah, how to take a transpose. We're gonna do transpose at, ooh, okay. I'm not comfortable with this. Uh, well, you never know if something's gonna work unless you try it, right? So we're gonna assign matrix. Let's go to grant, see how this thing works. So first, does it work on a square matrix? Don't need this. So we only care about this matrix down here and what's going to result in. So let's do that. That's a blank. And that's going to be, oh, need to transpose matrix first. What's wrong with this? This is saved. don't see what's wrong with this. Oh, I misspelled. Okay, does this work? So how does this thing get switched? Hold on, I'll figure something out. I'll be right back. I don't because that does not look like transpose. All right, so it turns out that this was a transpose. So the way this works is um is read from top to bottom, and that becomes what you end up reading from left to right. So it all makes sense. Now let's see if this works for non-square matrices. Let's give it an extra dimension. Um, just so we really see it from the set the very edge of it to get something ridiculously high. 87.2, so now we can really see where it's going. Let's check it out. Okay, so this is why we test our code, because we went out of bounds because we forgot to do something like this when you do when you write a swap in here. Let's do int. Alright, so then we can say rows. No, say rows to columns, and then we assign columns by what this is. Now it spreads out. So we from top to bottom to 1, 3.2, 0, -1, 0, 7.2. All right, this works. So that's our first matrix function. All right, so we're going to do two functions. So for now, we're going to do addition and multiplication. So multiplication is the one that's really what's important because that's when we're going to start doing transformation stuff. Anyways, well, it's good to have as many functions as possible because if you ever use this a later for let's say a pre-calculus class and you need to use matrices for some reason, uh, this is a good thing to have in your disposal. So let's write the add function. So call this m. That doesn't clash with anything. That's good. So first we're going to check the dimensions of this matrix because if we're adding a 2 by 2 matrix to a 3 by 4 matrix, that's not going to work out. So we need to check that. Let's say if the rows, so if they're not equal, or if the columns aren't equal, we say that the matrix dimensions must be the same or they must agree. Or we say unable to add matrices these of different dimensions. I think maybe later like we can go ahead and have this function take more matrices, maybe like an indefinite number of matrices. We'll see if we can. Well, that's later down the road because that's not important because you're gonna simply keep on calling add. as as your current option. Another thing that I think about doing is maybe like making our own custom exception. Yes, that's possible. So if you want to suggest any of those, I'm not going to prioritize those, but if those happen to be the only suggestions that I have remaining, then I'll definitely consider those because you are my viewers. So we threw the exception, and now we can safely add two matrices. Uh, that's, all right, let's see how this works. So let's try to add two matrices together. So first, we'll make sure that you can actually add two matrices of dimensions that agree with each other. Let's set this to a different value, -1. So if we add these two numbers together, this should become 0. And also, this is not matrix. This is matrix 2 because otherwise now we're overriding what we did here. So that would have been a waste of instruction. Do that set. So row 0, column 1. Set that to 1.8. So I'm looking at this value here, so this should add up to 5. In fact, since we're already like giving expected outputs, let's see if it actually gives the output that I said to expect. First, let's print out the original matrices. And then let's also print out the sum. And matrix 2, what is this? What is wrong with this? Oh yeah, because in case something's wrong, we should be able to do something about it. Let's put some spaces in between. Yep, so we have 1 minus 1, that gives 0. Then we have 3.2 plus 1.8, that gives 5. Then we have 0 plus 0, that gives 0. So the rest of the values stay the same, which it did over here. So it seems to be working. If you want to test more cases, I think that's a good idea. Let's do something outrageous. I'm going to call outrageous just something that we're going to try to do. This should hopefully fail. Sounds weird, but if this fails, this means that our program isn't letting us do bad operations. So these two are two different dimensions. So if we try adding them together, this should hopefully not throw an exception instead of going ahead and trying to do something with it. All right, looks like this works because this 3 and 2 disagree. 3 and 3, yep, so far so good. Let's do maybe one of, and what if we just gave it something big? Yep, it's not going to add a square matrix of size 100 to a 2 by 3 matrix. Okay, so that is good. Now we're going to do multiplication. Okay, so what we're really looking for, actually, you know what? With this multiply, I'm gonna say this to next week because this video is taking long, and this multiply will take more work than just a simple addition. And so yeah, we'll see you next time.